Good morning or afternoon, depending on where you're at in the world. I'm Dr. David Morrow. I'll be making a presentation with my good friend Lars Magnuson on the need for a common language for supply chain management and its importance to digital supply chains. I work for the United States Air Force as a Security Assistant Program Manager. I'm a certified SCOR P Master Instructor, as well as a certified fellow in production inventory management. I have worked consistently throughout my career with the SCOR P and the SCOR digital framework development. My experience spans many years from distribution that I did at UPS, procurement, which I've done here at the Air Force, from strategic sourcing and category management. I also ran operations at one point in time for a automotive remanufacturing operation. I've also worked a little bit in information technology as well as process modeling and design. I've also worked with the DCOR and the M4SC models for supply chain management, and have worked in the past for IBM, Bearing Point / KPMG, and UPS. I've earned my MBA from Ohio State and just recently completed my PhD in logistics from the Air Force Institute of Technology. So I look forward to today. Lars, I would like to hand it off to you. If you could introduce yourself, please.
Yes, my name is Lars Magnuson, old-time friend of David. We have been around for far too long in the SCOR business. I'm, as David has been the part of the SCOR development for a long time. My daytime job is at Ericsson, and currently working as an enterprise architect for what we call our lighthouse projects, where we are building sort of digital capabilities for the future of Ericsson. I have been with Ericsson for a very long time and have done a lot of things all the way from designing cardboard boxes to kind of being in control of the IT environment for the supply part of Ericsson. My night shift, I usually call it, because basically it's US based, so it ends up at night meetings in the late evenings. Has been involved with SCOR development, but also several other frameworks. Lately with the SCOR DE and the kind of the information model for SCOR that we will be talking about today. I'm also, besides being involved in ASCM work, doing lecturing at various technical universities in Scandinavia and in Russia, and doing that with the focus on the SCOR and supply chain management. My kind of career started at the master's degree in Master of Science in the University of Lund too many years ago, and I actually have the pleasure of once a year give a lecture in my old school, which means that I must have done something right while I was there. So with that, I think we are ready for today's presentation, and I hand it back to you, Dave.
Thanks, Lars. Supply chain management is incredibly important. Transform many organizations. We've heard a lot of talk about supply chains throughout the pandemic. Companies are more interconnected than ever and dependent upon their supply chain partners, domestically as well as internationally. It is our contention that supply chain performance would greatly improve if we had standardized information. There's a lot of talk about us moving to the information age, moving into the digital supply chain environment, where information is going to be incredibly important. I'm sure that everyone's aware that supply chain managers are highly dependent upon information because that's the raw material that they use to make decisions with. We've all seen the flow from vendors to sourcing to operations on through. The one thing that's very interesting about this flow is that material flows one way, money generally flows the other way in payments for goods and services, but information flows both ways. So it's incredibly important to our supply chains. One of the problems, however, we've got is we don't have a common language for supply chain. This was the basis of what I was doing my dissertation on, and I informally interviewed some people and just asked them some questions. Would a common language help you? And the response that I always got was, absolutely, we definitely need this. As I investigated this a little bit further, one question brought up to me was, do you have any examples where a common language has helped out trade or supply chains or anything similar to that? And the one thing that is very apparent is that with the British Empire in the 1700s, 1800s, being the dominant world force, they had colonized a lot of the world, plus or minus, I don't know, from an intellectual perspective and a human rights perspective. But the one thing that they did do was that it enabled the English language become the international language of trade. And you see this whenever you go to some of the major cities and port cities in the world where they understand English. And there's a lot of speculation, even with the rise of China, that this probably will not change. It'll probably stay the default language. So it helps us to be able to communicate with one another. One of the problems that I've seen, though, is if we don't have this common language that we're talking about, we can end up in a situation where we have the illusion that communication occurred and it really did not occur. We actually got wrong terms. I know in talking with some people on some work that they were doing in China, we talked about supply chain financing. My concept of financing from the United States perspective was vastly different than that was going on in China. So we thought we communicated, but we didn't. Classic Tower of Babel, if you will. Common language can enhance our understanding and increase the flow of information and decision-making because we don't need to ask for terms to be defined. It's critical to increase emphasis for digital supply chains is this focus upon a common language. When we move to the digital environment, actors are not only human actors, but they're also computers that are integrated and communicating back and forth. We need to make sure that that information is shared in a consistent format to where people can understand it, as well as the computers understanding it. And as we'll show here a little bit later, not only does it save time, but it also saves money. So how do we do this? One of the best practices that's out there is to utilize some kind of a supply chain framework or some kind of a process framework that kind of defines what the inputs and the outputs are and what we're trying to achieve. There's a lot of different models out there that talk to supply chain. This is just one of them that was proposed by Fawcett and Magnan in 2001, and it just shows high-level integration of the form, or the integration with the various actors within the supply chain. So what we need is some kind of a mechanism that'll get us beyond just suppliers talking to focus firms and as such. We need to get on down there, because down to the lower levels. The thing that we found was that an ontology is the best way to do that. Ontologies can really start getting confusing when you start trying to understand what exactly they're about. An ontology is nothing more than just a file structure or a work breakdown structure. It just identifies processes and inputs and outputs, if you will. The formal definition is the study of the kind of entities and relationships to one another, which is quite honestly one of the more user-friendly definitions that I've heard out there. Provides consistency in the terms, the definitions, and those metadata descriptions. So I don't need to know how you specifically define it in your specific company. What I need to do is understand what that data is trying to tell me. It allows computer science to code the knowledge and enhances the data sharing. One of the classic examples is biomedical research has really seen a great increase in solving problems because they have mapped out a lot of what they do in relationship to a basic formal ontology. However, one of the problems that you run into when you start developing an ontology is you want to make sure that the development is includes knowledge practitioners, people who understand, in this case, supply chain, but also technical experts who can code in the information and make sure that they've got it right. One of the best practices is to start with some kind of a lightweight ontology. A lightweight ontology is what we understand as human beings. We can see it, look at it, and understanding it. One of the classic examples is a folder structure you utilize on your computer. In addition, a work breakdown structure is also a good way of looking at it. The thing I always look at is just think of the animal kingdom, the way we broke that down into the various reptiles, mammals, and then the subspecies of those. That is an example of a lightweight ontology. For a computer, however, we need to use computer coding to get it to be able to automate communication back and forth. That's where we get into a basic formal ontology, or what is also known as a heavyweight ontology. It has much more rigor and logic, and the definitions are explicitly explained. One of the best practices is to start from a lightweight ontology to build a formal heavyweight ontology. A basic formal ontology is going to be the basis of our foundation for our digital supply chains. If we do not have that, I think we'll have, once again, the computer aspect of the Tower of Babel. Once again, the best practice is to begin with a well-known and accepted framework, something that everybody understands. In this case, what I looked at several different process models, if you will, for supply chain. And the one that I ended up landing on was SCOR 12.0. In this case, the SCOR process hierarchy not only has processes within it, but it also has performance in the form of metrics, has some best practices to help you solve problems and to get better in a given process. And it also has skill sets identified for the people. So all of those get linked together into a standard framework. Now, how did we go about doing this? What I did was I took the SCOR model 12.0, utilized it to build a model of the SCOR 12 in a software platform called Protege. In Protege, what it does is you can key the information in, and it's relatively user-friendly as far as building these processes and these file structures. And then all you have to do is just hit a button and it produces the OWL ontology language, is what you need to develop an ontology and utilize an ontology. Excuse me. But as you can see here, in comparison to the previous slide, we have the metrics, the practices, the processes, and the skills. One of the things that was important with the SCOR was that make to stock, make to order, and engineer to order are all considered separate, and there's no overlap. OWL assumes that there's an overlap, so we had to go in and make those processes disjointed. One of the cool things about the ontology is that each process has 5 object types. And these are the, you hear somebody talk about the ontology and the OWL ontology, they start talking about triplets. They start talking about the object, subject, and predicate. You can identify those within Protege fairly simply, as you can see at the bottom part of the screen, and that allows this all to be linked together to make a more complete model, if you will. Some of the data properties in the Protege software is we set the data type at a metadata hierarchy to where we can identify what kind of value. For example, one of them that we run into is value at risk, overall value at risk, and how that is calculated. So one of the key reasons that I utilize Protege is because I did not want to code the supply chain model into XML/OWL. As you can see here, this is some pretty detailed information that could make you leave you scratching your head. Not that it was easy utilizing Protege, but it was far easier to use Protege to get the output for the XML and the OWL. So all of that being said, looks like a very interesting process, a very interesting topic, but so does this actually work? Can it help me save time? Can it actually help me to save money? At this point in time, I'm going to turn it over to my friend Lars Magnusson from Ericsson to show you what they did and to prove out the case for this ontology. Lars?
Thank you, Dave. The first time someone said ontology to me, now I said, what? And then they said ontology again, and I said, please speak English. And then the kind of definition popped up. I was looking up on my phone here, the kind of reference to itself and to others, and didn't really get it. So in a couple of years ago, we formed a small special interest groups under the ASM umbrella to actually see what you could do with this. We created a small consortia consisting of kind of a high-tech supply chain, where we had Infineon as a kind of semiconductor manufacturer, supplying things to Nokia, one of our key competitors in the world, Ericsson, and as well to a company named Rohde & Schwarz that are doing advanced telecom measurement equipment. To our help, we had our tech team from a company named Essenza, our friend Chris Brockman, and we also had significant support from SAP in the background for this. But the idea here was that we were trying to find something where we had, so to say, a natural interaction between each other. Although there's not much sideways interaction between Nokia and Ericsson, but of course we know of each other, and we are fierce competitors. But when it comes to these type of things under the kind of standardization umbrella that ASM offers, it of course enables even fierce competitors to collaborate on the validation and development of new ways of working. So we started off with, so to say, we said put up an test bed, you can call it, where we jointly pitched in a small amount of money to actually get the work done. We created an ontology, so say, and a storyline for how we related to each other, and we decided to do this in 2 phases. So the first phase, we were looking at kind of slow-moving data, things like, and you could call it master data. So thinking about the kind of partner information that could be addresses, it could be what type of relationship you have, and you name it. So that was the first step, and because when someone said, coming back to the word ontology, now we couldn't grasp the concept. So we actually together in a working team sat down and created this. We used the SCOR model as a starting point. There we have good help from a German research institute named Fraunhofer that had done some really good work on how to create a kind of a SCOR ontology. So we picked out pieces of that and started to create, so to say, a manual interface. Basically, we could have used smoke signals to signal to each other, but we went a little more high tech than that and used the internet to exchange slow-moving data from Infineon to Ericsson, and from Infineon to Nokia, and also we had some exchange between Ericsson and Nokia, although of course we were working with perfectly the kind of neutral data, so that worked out as well. But it was a way of getting the touch and feel of an ontology. What does it mean when you say that an order has an order line? An order line is connected to a product. This may sound like a typical logical information model to you, but the thing with ontologies is that it gives you the ability to give statements in natural language descriptions that at the end of this, you can actually, the machine can actually start to make conclusions from it that you didn't see from the beginning. And that is the real interesting part with the ontology creation. It actually, you collect information in a digitally consumable way that is very, very hard to do with traditional information models, as well as with process modeling. Now, in the start, now if you can think about this as now, traditionally you would do, so to say, an information model of your flow on one wall of a conference room, and then you would do a process model on the other wall, and then you would be standing in there in between and trying to understand how they connect. What you do with the XML that Dave was showing you, the cryptic code that he ended his presentation with, is that you actually have someone sitting in the middle of the room taking down this code as you speak. So you basically combine your information modeling with your process modeling in natural language terms in the computer. And this is what we did in the kind of this corporate data phase. Then we decided to test the kind of how could we actually do something with regards to interaction between each other. And then we picked out a very simple order process. We're looking at kind of a purchase order from Nokia to Infineon, and the kind of the confirmation coming back from Infineon to Nokia. So basically a two volley conversation, very, very simplistic. And the important element here is that now we have the shared vocabularies that we created jointly based on SCOR. And then we said also here that now we wanted to make sure that this could be duplicated across multiple parties. And that's one of the reasons why we had one seller of things in Infineon, but you had 3 buyers. So we had Rohde & Schwarz, Ericsson, and Nokia. And we should be able to kind of align sideways without having to negotiate together. And that was kind of what we call the secure many-to-one. The basic idea and the objective of the whole program was to see if we could add a partner to a conversation like this at 0 marginal cost. And for anyone having worked with EDI, you know that the bilateral way of working with EDI costs quite a lot of money, and it is always you and your partner, and depends on who is the strong in the relationship. If you are the buyer, you usually kind of tend to over trump the seller. Perhaps not all the time, but many times that is the case, and that means that you get kind of tweaks built into the system. And what we're trying to do here is to make sure that we can handle all tweaks in a multilateral way from a single vendor, in this case Infineon. The process that we were trying to emulate was the kind of the ordering domain. And this one, I have borrowed this little sketch here from an organization named Edifice, that is the kind of the high-tech industry EDI organization in Europe. So we looked at that and say, okay, what is it that we are? What does the process description look like? And if we would do this with an ontology, what would it be? And anyone having worked with a kind of this is a five volley message exchange here, starting with the purchase order, having a purchase order acquisition, acceptance, and then, so to say, various other messages behind this. You know that you're packing those messages with a lot of data. So you're sending and you're pushing out data in from the kind of from each of the parties to the receiver at the rate that can be very high, but you push out a lot of data, and a lot of that data is redundant. What we try to do then, and the intention is not for you to read all the fine details here, but basically we combine these 2 use cases that we said if the step 1 and step 2 of the proof of concept. So in the green boxes we had the slow moving data. In one area we had the kind of the product data in the lower part. So the product numbers, pricing, things that weren't changing that often. In the top box, we had the kind of the business data. So that would be locations, the typical means of mode of transport used, those type of things that, once again, now didn't change very often. In an EDI message, then you would actually take that, and that would go, so to say, into the header and bottom of the message, and then you would have a payload, which would be, so to say, the really important stuff, which would be the kind of the middle part, which is kind of the order now type information, and say, okay, I agree type information. And what we did here is that we kind of by utilizing the ontology approach, we could actually separate. So we had less data traveling in total, but we had kind of two channels, one for the slow-mo moving data, which is the kind of the greenish part, and then the very high velocity thing that is in the blue. So a signal from a buyer saying need product now. And that's all you need to transmit. So you have a product number and a quantity. All the other data you would find in the greenish part, so you can cross-reference that. But that would kind of travel at a different clock speed from the blue part. So that was one thing that we built up an ontology to do that, and how to describe that. The other part that we actually did here is that traditionally you would push out the data. So the one procuring items would send something to the vendor, and the vendor would send something back. In this case, we actually use the technology we call publish subscribe, where we kind of, and if you are familiar with the kind of API development, this is one of the many options that you can have in an API when you create an API. Basically meaning, and the analogy I use is that you publish your order on a billboard that is uniquely accessible for your vendors. So, and you agree on the frequency of updating that billboard. So it can be done once a second, once a minute, once an hour, once a day. But everything based on certain business rules that you have agreed on beforehand, you know that at this moment, I have the latest and greatest information available from the other party. And then I download it at my will. So it is published, and then I subscribe to it and pick it down when I'm ready to execute on it. And this is a significant change, so to say, from the way that we have been working with kind of when you have the more when you're pushing information to the other party, because then you're putting a lot of dependency on translations and network capacity, as well as on various type of data management on the receiving side. You have your machine may be down, and then you have a kind of you have a queue of messages coming in, and then you start your translation machine again, and you miss every second one for some reason, and then all of a sudden you have a kind of a customer that is they're very irritated because they their work hasn't started. So kind of prone to hiccups and all types of possible potential delays. Of course not. What I'm saying here, and this is very important, is that now what we have tried here is to emulate the idea of EDI. The idea here is not to replace EDI, because the EDI has its place in the kind of the means of communication. The key thing here is that you need to have a portfolio of things when you're working with what we nowadays call the Internet of Logistics, where you use the tool that is fit for purpose. So if you are in need for a high speed, high accuracy, high security kind of data exchange, ontology-based communication can be one mean. If you are in another situation, you may be more kind of inclined of using a direct API or a traditional EDI message. So the idea here is not what we were trying. It's not trying to overtake or overrun any of the existing technologies, but rather so they be able to offer to complement existing technologies for exchanging data between two enterprises in a ways that is fit for purpose. We also had, so to say, a third step involved in this, where we were trying to kind of do the publish, subscribe, and ontology part here described in the middle, kind of integrated all the way from ERP system on to the left to ERP system on the right. What we realized here is, of course, that here we had in the kind of the consortium, we were kind of geeks talking to geeks. So there, of course, we could move quite fast. But when it came into the phase of actually doing adaptations inside the firewall of each stakeholder here, we found that was something that needed more time than we have anticipated. And partly because this was coming from from the logistics team of various companies that we had forewarned IT that this was coming on our respective sides, but we were kind of breaking the norms of IT in many places. So this was a disruption to them, and this took much more time than we anticipated. But I should say that now, after the proof of concept was finalized, we actually, all of us have done have had this set up in an appropriate manner. It's just that the first time around, it was took a little bit more time than anticipated. So as usual, change management is key in when you do this type of disruptive changes. So what did we do? Well, from a technology perspective, now we separated the slow-moving data from the fast-moving data needs, and I think that was a key item here that I will come back to later. We changed the push, traditional push, into a pull through publish subscribe APIs. We also use something we call linked data. Dave hasn't touched on that very much, but the principle here is that instead of copying, sending a large set of data as a copy that you download somewhere and then you use it later, instead of doing that, on the publish subscribe end, the data stayed where it rested. So we took data directly from the ERP system through a link into the billboard that I talked of before, and so the data actually never moved. It was just a pointer that you subscribed to, and that was ensuring that we could secure a lot of good features based on that. And last but not least, we used a very simple technology blockchain application here, where now on the billboard we actually took it, and you can see it like the equivalent of a photo of the data that was published, and then we store that and say here is and a photo of the data that I just published in blockchain technology that is called a hash. And by using a public key encryptation, you could then say when you had downloaded and subscribed to the data and put it in the place, then you could redo the hash, and then you compare the two to each other, basically a checksum. And if it came out exactly the same, nothing has happened on the way between the point A and point B. So no one, even though we were using public internet for transport, they were transporting the data, nobody had tampered with the data. So that was just a simple extra security layer that we tested. Of course, beyond this, you can have a number of other types of encryptations and tunneling and other things that on top of this. But we wanted to test to verify if that would be, because that would basically enable you to have a traffic light situation where if the data had not been touched, then you would have a green flag on the data set. Now, if someone had tampered with it, well, you would have either a yellow or a red flag saying that now be cautious before you ingest this data, because something has changed from the source. So the impact of this, well, for the the separation of data, of course, this meant that we had for the operations was less data used. Less data traveling. It meant that from the subscription into use of the data, there was less translations to be done, so you could actually move faster with the data. Yeah, basically creating a higher flow efficiency in the data in the data pipeline. Of course, then combined then with the publish and subscribe, where we only moved data when it was needed, and where, so to say, we took away, I would say, the key finding here was the less risk for interpretation errors, because now every time you store and then reuse, you will find that someone may have done something to your data, either by intent or by mistake. Same thing with the linked data, kind of leading to less manipulation of data. And especially if you ever have done, so to say, what we call a CRUD analysis of the data flow. CRUD here, not meaning what you think, but rather create, read, update, and delete analysis of data elements, where you actually look at who is doing what to your data as it travels along a value chain. A very interesting exercise, and you will be surprised how many times you find people where you think that people are reading data, where in fact they are actually reading and then updating. And that is really a pitfall when in long supply chains. And then, of course, the hash technology was kind of a simplistic way approach to building trust on in the trade between two parties. The metric here that we put in place was to kind of to get the faster operational use on the receiving side. And remember that I said that the kind of the overreaching goal here was to be able to add a vendor to a flow at very low marginal cost. We said zero. It wasn't quite zero, but it was less than what a typical EDI implementation would cost. Then there are some business impacts. So as I said before, now the idea was not to take away EDI totally. The idea was to complement and adapt data integration for different needs. So use the appropriate tool or fit for purpose tool for the problem at hand. So this was an addition to the portfolio of tools that you could use. We were also kind of looking at now how could we get better at the kind of aligning, planning. And as you saw, you had Ericsson and Nokia. Both of us are installation-heavy, project-driven companies. Now, how could we actually make sure that the hardware and installation were kind of better synchronized? And last but not least, now how could you get earlier involved in the setup? And if you remember, so to say, the separation of fast-moving data from slow-moving data. The slow-moving data, you can have months ahead, and there you could actually see delivery sites. You can see locations. So a number of planning data can actually be picked out from those slow-moving elements, which enables you to kind of build and predict what your supply chain will look like. And then, so to say, the call-off signals, the small set of data needed to actually initiate the transaction of manufacturing or shipping. That is, of course, also important, but is for other purposes. So once again, we were looking at, so to say, at the project at hand here to have faster operational use on the receiving side. We wanted to be able to kind of, in a theoretical world, be able to switch from, so that so say Infineon could switch customer or Ericsson could switch from Infineon to someone else in a very fast turnover. And then, of course, now as we get into more aligned and kind of less waiting time, you get less materials, less stock waiting for services, for resources in the supply chain, so that things are available much faster. And last but not least, to say the early involvement gives you a possibility to plan your supply chain, which of course will have an impact on cost. But we also had the sidebar on kind of the environmental impact from having less transport or more efficient, bigger load factors on trucks, which will have, so to say, a CO2 impact. So that was, so to say, and that this is one of these good things where supply chain costs and emissions actually go hand in hand. You lower one, but both actually goes down, and that is really pleasant when you get into those situations. So if you sum this up, we have, and this is, so to say, a simplified Dupont model that we have used to express now what happened. So we have, so to say, the revenue and the expense side on top. We weren't really looking at the revenue in this small proof of concept, but rather looking at this expenses. And the revenue and expenses now, they will lead up to a kind of a profit or a margin. On the lower hand, we have the working capital and the fixed capital. When we were not, so to say, so much looking at the fixed capital in this. And that leads up to a capital efficiency. And at the end, if you take both of these, they kind of lead up to the company value add. And in our calculations here, you find that now the supply chain cost, actually we could lower that somewhere between 1% and 3% of that is supply chain cost of the cost for supplying over total turnover. And when you look at inventory turnover, we are looking at kind of a number of how much capital you could actually save by being better integrated. And summing up, so to say, somewhere between 2% and 5% of your turnover is actually addressable here. And if you take the next click, Dave. The keyword here is really flow efficiency. So we are actually tying kind of high-tech IT tools back to lean philosophies. So instead of having resource efficiency in various silos of IT, we actually through the ontology approach and the graph approach here actually ended up with less waiting time and a more integrated flow across several stakeholders in the value chain, and thereby, so to say, creating flow efficiency. And flow efficiency, well, it kind of led to this paradox that you actually both save cost as well as inventory. And this is that type of double whammy is really interesting when you find those opportunities. Should also say that here that now, if you think that this, when we started with a small setup in this consortia that you saw in the beginning here, this has actually grown now, and in various areas. One of the examples where Ericsson has been very active has been in creation of something we call the Internet of Logistics, which is based on these type of tools. And one of the best examples, if you're interested to see, is to actually go to the International Air Transport Association, IATA, and check on their one record setup. There they have done the same type of setup, but they're, so to say, in the relationship between freight forwarders and airlines. And my friends at IATA, they haven't kind of shown yet how much money they are saving on this, but the kind of the flow efficiency effect is highly visible there. And so that is one of the kind of the larger scale work that has happened. What you should be aware of is that if you are a SCOR interested, if you go into the digital SCOR DE, SCOR Digital Edition, the one that actually supersedes what Dave was showing here, the SCOR 12, there is actually a section there on a special application that is showing the kind of the SCOR data, SCOR information model, and where you can actually go into much more detail and look what we actually did in this special focus forum, because that was the starting point of actually trying to create and describe a lightweight SCOR ontology, not as because Dave has gone onto the heavyweight part, so actually going one step further, but that was the kind of the starting point for ASEM to actually work in a clearer way with the ontology approach and combine that with SCOR and perhaps other frameworks that are available in the ASEM portfolio. So Dave, what do we say about this then?
Lars, I've got a couple of quick questions I want to get some clarification on. So you're telling me that what you did with this, you were able to lower costs by onboarding suppliers, new suppliers quicker and faster, but that would also increase your supply chain agility, correct?
Definitely. But given, so to say, we spent approximately 3 months on this proof of concept, so we on purpose we stayed on few selected items.
Right, understood. Which also brings me to the second question. Interesting, you only used a certain portion of the SCOR model. You didn't use the whole thing, right? You just used the order part, correct?
Correct. So it was the deliver part that we tagged on to, based on what Fraunhofer Institute had done. They gave us very good support on, so to say, how to kind of interpret, because they have done a heavy ontology, and we kind of did a little bit of backwards tracking from that.
Okay. So when you utilized that deliver portion, you went in to integrate the information from your perspective into a SCOR definition. Is that how you link that up, or?
That is the way we did the kind of the ontology work, and we weren't perhaps the most zealous SCOR users at the time, because this was quite early on. And we have learned a lot. All of us that participated have learned a lot since we did this. But this was a starting point for a development, both at Infineon, that is very advanced with this, but as well as with kind of in discussions between us and Nokia, which has been very interesting from a standardization perspective.
So the language, the common language, helped you out here as far as communicating with various suppliers.
Definitely, and no, that was also one of the reasons why we had fierce competitors as part of the POC, because that was kind of not naturally exchanging data sideways between each other.
Okay.
That is kind of that wouldn't happen. That do not normally happen. But of course, then the opportunity that ASM offers with this special focus forum for members to actually try things out, and then kind of utilizing the intellectual property of ASM as a foundation is, of course, was a very valuable input to this.
Yeah, personally, I've seen numerous mapping and process improvement efforts get bogged down in term definitions. And this is a great way to, that I've utilized in the past to identify common terms and definitions to move us off the mark of arguing about this. Well, thank you much. So I guess I will close this out here. One thing that I've seen through this research and working with Lars and a lot of other suppliers and buyers in this new age of the digital supply chain, one of the key drivers is big data, but as I've seen, big data only makes sense if you know what you're talking about. So thank you very much. And with that, we will give you back your afternoon. Thank you.